जय हिंद स्टूडेंट्स, आप लोग कैसे हैं? वेलकम टू माय यूट्यूब चैनल. एंड स्टूडेंट्स, our greatest weakness lies in giving up. Students, for you, it's a mere suggestion that while solving articles, while solving numericals, while studying some concepts, if by chance you are unable to understand or you are unable to find solution, never give up. The certain way to succeed is always to just try one more time. So please students, keep trying and you will definitely succeed. So with that, let's begin this particular episode or this session. In this particular lecture, we will be discussing the resolution of a vector, right? So for that, let me introduce this topic by stating that we have discussed triangle law of vector addition, we have discussed parallelogram law of vector addition. These are the two laws which are helpful in the addition of two vectors. And in case of more than two vectors, if they are to be added vectorially, then we make use of polygon law of vector addition. Students, this process of addition is known as composition of vectors, while the reverse of composition of vectors is known as resolution of vectors. Resolution means actually the splitting up of a vector into two or more components. The splitted part of the given vector is known as the components of the given vector, right? So I'll give you an example. Suppose these are the two vectors, A vector and B vector. Suppose they are inclined at an angle theta, right? These are the two vectors acting simultaneously at point O. So obviously their resultant would be given by this. Their resultant would be given by the diagonal of the parallelogram formed by A vector and B vector. This is the resultant. Clear, students? So we are vectorially finding the resultant of these two vectors. So R vector is the resultant of A vector and B vector. This method of finding the resultant of the two or more given vectors is known as composition. It is known as composition of vectors. It is known as composition of vectors. So the result produced by these two vectors collectively at point O would be the same as that of the result produced by this R vector when acting at point O. So R is the resultant of vectors A vector and B vector. So finding the resultant of the two given vectors, that is known as composition of vectors. Now what will be the reverse process of this? A vector is given. Second scenario is a vector is given. This is R. It is given. And it can be splitted into two or more components. Suppose it is splitted into one component along this direction, A vector, and one along this direction, suppose B vector. Such that whatever effect is produced by this R vector at point O is produced collectively by A vector and B vector when acted simultaneously at point O. So R vector, it's the given vector, it is being splitted into these two components. These two splitted components of this given vector are known as the components. So here we have got the resultant of two given vectors, and here in this case a vector is given, we have split it up into two or more components. Right? So this process of splitting up of a given vector into two or more components is known as resolution of a vector. So that is the reason why I have stated resolution of a vector is the reverse process of composition of vectors. Right? I hope you have understood this concept. Now what we will do is, if it happens that I split a given vector into two perpendicular components which are mutually perpendicular to each other, making an angle of 90 degrees with each other, then those two components, those two perpendicular components of a given vector are known as its rectangular components, right? So we'll discuss the rectangular components first, right? So let's start with the actual topic now. So the rectangular components of a given vector. First we'll discuss in 2D and then we'll discuss in 3D. So first let's discuss the rectangular components in a plane. Rectangular component in a plane. Rectangular components in a plane, that is 2D case. Rectangular components in a plane. So let's consider this to be x-axis and let us consider this to be y-axis and let us consider this to be the origin. Students, we are already aware of unit vectors. You must remember I cap, j cap, k cap. These are the unit vectors representing the direction along x-axis, y-axis and z-axis respectively. So here we are dealing with two-dimensional case, x and y in a plane, right? So the direction along x-axis, that will be represented by I cap. The direction along positive y-axis, that will be represented by j cap, right? Suppose this is any point P having coordinates of x and y, and this is the position vector, r vector. We are aware position vector is a vector whose tail remains fixed at the origin and its arrowhead coincides with the instantaneous position of the particle. Position vector is a vector that represents the position of a particle with respect to the origin, right? Suppose its coordinates are x and y. So if you drop a perpendicular over here, suppose this is m, this would be x and this distance would be y. Isn't it? We are aware of it. So if you drop a perpendicular to the y-axis, it will be like this. This dimension would be y. Suppose this is O, M, P and let us consider this to be N. Clear, students? Now look, it's a parallelogram, it's a rectangle, right? And these two are perpendicular. We need to resolve this given vector r vector into two components, one along the x direction, the other along the y direction. And since these two are perpendicular to each other, therefore those perpendicular components so obtained will be known as rectangular components. Right, students? Okay, now what to do is, let's represent it in vector form. OP, it will be written as r vector. Right? OM, OP vector is equal to M. OM vector, its magnitude is x and direction is along x-axis, x I cap. Look, vector, it has got two parts. One, the magnitude and the other, direction. X represents the magnitude of OM, I cap represents the direction of OM. Clear, students? OM is having dimensions of x along x-axis. Similarly, MP or ON vector, it is equal to having dimensions of ON, which is y, and along y-axis, that is j cap. Clear, students? Okay. Now this is a parallelogram, or you can consider it to be a rectangle. In a parallelogram or a rectangle, every rectangle is a parallelogram. Opposite sides are equal as well as parallel. Therefore, ON vector is equal to MP vector. This is MP vector. Right? And NP vector is equal to OM vector. Clear, students? Now in triangle OMP, applying triangle law of vector addition, we get, now look, these are OM and NP are the two sides of the triangle taken in the same order. So their vector resultant both in magnitude and direction would be given by the closing or the third side of the triangle taken in the opposite order. So what you get is OM vector plus NP vector is equal to OP vector. Am I clear, students? Now let's substitute the values. OM is equal to xi cap. Cap, this is cap, caret or hat, that represents unit vector having magnitude of unity. It only represents the direction of this given vector. Plus NP. MP, now look, this is NP. NP is equal to ON, right? NP is equal to ON, which is equal to yj cap. OP vector is equal to R vector. So this is the first step. If coordinates are given to be xy, then R vector, which is the position vector, will be represented in terms of I cap j cap as xi cap plus yj cap. Clear, students? Okay. Now let's find its magnitude. For that, what to do is, suppose it subtends an angle theta. Suppose the R vector, which is the position vector at point P, makes an angle theta with the x direction. Now in triangle OMP, consider sine theta. It's equal to perpendicular by hypotenuse, that is y by r, or y is equal to r sine theta. Put this as equation 2. Similarly, consider in the same triangle cos theta. It is equal to base over hypotenuse. So cos theta would be base O2m, the magnitude is x, divided by hypotenuse is r, which implies that x equals to r cos theta. Clear, students? Now, in order to eliminate theta, what do you do? Adding and squaring. So, squaring and adding 1 and 2, we get, in the left hand side will be getting x square plus y square, and in the right hand side r square can be considered to be common, and it is sine square theta plus cos square theta, isn't it? Sine square theta plus cos square theta is equal to 1, therefore r square is equal to x square plus y square, or r would be equal to square root of x square plus y square. So if x and y are given, then the magnitude of the resultant is given by square root of x square plus y square. And students, remember, this, it is known as the component of r vector along y direction. X, it is the component of r vector along x direction. So these are, x and y are the rectangular components of the given vector r vector. Clear? Whose magnitude in terms of x and y would be square root of x square plus y square. And also, you can find out the value of theta. Dividing third from second, what you get is y by x is equal to r sin theta divided by r cos theta. R sin theta divided by r cos theta, which will give us tan theta is equal to y by x. So this will give us the angle which r vector makes with x axis. Yes, friends? So just check this mathematical steps, and then we'll be discussing some interesting cases, right? So this will give us the magnitude of the resultant, and this gives the direction which r vector makes with x axis. Now let's, before proceeding further, let's discuss some basic questions. Suppose what to do is, let us consider a body to be positioned at point Q and having coordinates of 3 and 4. Right? This is the origin. This is x-axis. This is y-axis. So, what will be its displacement? Write the displacement of this body with respect to the origin in vector form, as well as try to find its magnitude. So, x is 3 units, y is 4 units. So R vector, just now we have discussed, just now we have verified, it is given by xi cap plus yj cap. Thus, in vector form, the position vector would be given by 3i cap plus 4j cap. Clear, students? Now what about the magnitude then? What about the magnitude? R in magnitude would be given by square root of, the coefficient of I is 3. So square of 3 plus square of the coefficient of j cap, that is 4. Because just now we have proved R is equal to square root of x square plus y square. X and y are the coefficients of I cap and j cap respectively. So what do you get? R would be equal to 5 units. Clear, students? So x is 3i cap, y is 4j cap. The displacement along y-axis is 4j cap. The displacement along x-axis in vector form will be represented by 3i cap. And this is the position vector, and this is the magnitude of the position vector. Clear? Similarly, students, another case. Suppose this is an object and a force of 10 Newton is acting in a direction making an angle of 30 degree with the x-axis. Let us consider a force of 10 Newton to be acting on a body which is inclined at an angle of 30 degree with the x direction, right? We are supposed to find out the component of force along the x direction and along the y direction. Now we are aware it has to be splitted. It has to be split in two perpendicular components, right? So one of the component is like this. It can be considered to be Fx. Fx is the component of force along x direction. The other one would be along y direction. This is Fy, such that these two are perpendicular to each other. So Fx is the component of force along x direction. Fy is the component of force along y direction. So these are the two rectangular components of this given vector F. Clear, students? And always remember, this force acting at this point of the body will produce the same effect as the effect produced by these two components collectively when acting at point O simultaneously. Clear? So you can consider the vice versa as well. F is the resultant of Fx and Fy, or Fx and Fy are the components of F. Clear? So let's find out Fx and Fy. Now just now we have considered this is theta. Here theta is 30 degree. What is Fx? Just now we have considered it is F cos theta, isn't it? And what about Fy? It is F sin theta. Theta is this angle which F makes with the x-axis. Theta is the angle which the given vector makes with the horizontal axis. So that horizontal component would become that vector magnitude times cos component, while the vertical component would be the magnitude of the given vector multiplied by sine of the angle, sine theta. Right? This is what I have written over here. And in the vector form, F vector would be written as Fx I cap plus Fy j cap. So basically, Fx is F cos theta. I cap, you can write it like this also. Fy is F sin theta, and over here j cap. This is the correct way of writing in vector form. This, as I told you students, it is the horizontal component of force and it is the vertical component of force, Fy. Right? Now let's find its magnitude of the components. So what about Fx? It is F cos theta. F is 10 cos 30 degree. So it will be 10 into cos 30 is half. In fact, root 3 by 2. So it will be equal to 5 root 3 Newton. What about Fy, students? It will be F sin 30. Sin 30 is half. So 10 into half. So that will give us 5 Newton. Clear? Let's do the converse step, reverse step. The resultant of Fx and Fy should give us 10 Newton. Now students, look. these are the two vectors which are at right angle to each other. So whenever the two vectors are at right angle to each other, then the resultant is given by square root of fx square plus fy square. This is the formula. A and B vector, if both are perpendicular to each other, then the resultant is given by square root of a square plus b square. You can substitute the value of fx and fy over here, you will get 10 Newton only. Let's do it. So it will be equal to 5 root 3 square plus 5 square. So what do you get? So this is 25 into 3, 75 plus 25. So it is square root of 100, which is equal to 10 Newton. Thus verified. So students, I hope you have understood the composition of vector and resolution of the vector. Right? So this is how we can resolve a given vector into two perpendicular components. And those perpendicular components are known as rectangular components. So this was a two-dimensional case, rectangular components in a plane. Now students, let's discuss rectangular components in a space. That is, we'll consider a 3D case. Let's consider the resolution of a vector into three rectangular components. Okay, resolution of a vector into three rectangular components. So for that, what we do is, suppose we draw a cuboid. Okay. Let us consider this to be the origin. Let's consider this to be the x-axis, right? This to be y-axis, and let us consider this to be z-axis. Clear, students? So this direction will be given by I cap. No doubt regarding this. Y-axis, its direction is given by j cap. Z-axis, which is along this direction, it will be given by k cap. And let us consider this to be point P. Having coordinates of this is point P in space. We are dealing with 3D case. So suppose its coordinates are x, y, and z. Clear, students? So let us consider this to be n. Let us consider this to be n. This to be p. Right? Okay. Now what to do is, let us represent this to be r vector. Okay. As we are aware, a cuboid, it's made up of 6 rectangular faces, right? And in a rectangle, opposite sides are equal as well as parallel. So, suppose this is OMP, this is OQ. This side is equal to this side. Now, let us represent it in the vector form. OM, let OM along this direction. It is equal to OM along x direction. It is having magnitude of x, and along x direction. So, it will be represented by I cap. Right? O, suppose it is, let us consider this to be L, OL. OL has magnitude of y, and along y-axis, so it will be j cap. And students, OQ, it has dimensions of z, and it is along z-axis, so it will be z k cap. I hope you are understanding this concept, right? So, now what to do is, let's consider this triangle. Let's consider this triangle. Okay, consider triangle OMN. Now look, as I have told you, OQ vector is equal to MN vector. So I have indicated the vector from M to N like this. So this is a triangle where we can very much make use of triangle law of vector addition. Right? We can make use of triangle law of vector addition. So in triangle OM and MN are the two sides of the triangle taken in the same order. So the vector resultant would be given by the closing side of the triangle taken in the opposite order. So let's make use of triangle of vector addition. What do you get? OM vector plus MN vector is equal to OM vector. That is OM vector. OM, it is X I cap plus MN. MN vector is equal to OQ vector and OQ vector is Z K cap is equal to ON vector. Put this as equation 1. Clear, students? Simply I have made use of triangle of vector addition, nothing else. Now consider triangle this one, ONP. ONP. Now look, this is OL vector. It is equal to NP vector. These two are equal vectors. These two are equal vectors, isn't it? Now consider this triangle, this one. So these are the two sides of the triangle taken in the same order. ON vector plus NP vector. These are the two sides of the triangle taken in the same order. So the vector resultant as per triangle of vector addition would be given by the closing side of the triangle taken in the opposite order. So let's make use of triangle of vector addition. What do you get? ON vector plus NP vector is equal to OP vector. ON vector from equation 1, what we can write is xi cap plus zk cap. What about NP vector? NP vector is equal to OL vector. Look, NP is equal to OL vector and OL vector is yj cap is equal to OP vector. OP vector is R vector. So students, what we have derived is if the coordinates of a point in space is x, y, z, then its position vector is given by xi cap plus yj cap plus zk cap. So this is what we have proved mathematically by using vector algebra, by using triangle of vector addition. Clear, students? So if it has got coordinates of 1, 3, minus 4, then in the vector form it would be given by what? X 1i cap plus 3j cap minus 4k cap. So this is the proper way of writing a given point in position vector, in terms of position vector, in vector form, in terms of I cap, j cap and k cap. So this is in vector form. Right, students? Now let's find its magnitude. While calculating the magnitude, we are aware the magnitude of this, it will be equal to the diagonal of the cuboid. R, its magnitude of R will be equal to the diagonal of the cuboid of dimensions x, y and z. Right? So it will be equal to, and you are aware, students, if a cuboid is of dimensions x, y, z, then the diagonal of a cuboid is given by the square root of x square plus y square plus z square. So over here, the coefficient I is x, so square of x. Coefficient of j is y, so square of y, plus coefficient of k is z, so it is square of z. So this one will give the magnitude. It is actually the diagonal of a cuboid of dimensions x, y and z. Clear, students? This you must have proved in mensuration. Clear? So we'll continue in the next lecture then. Thank you.